Today's topic is the beginning of quantum physics. Why is it important and how is it different from regular Newtonian physics? But it didn't account for a very specific problem. They found that different colors of light, and actually whether or not it was ultraviolet, that means more than purple light, a color higher than purple, ejected more electrons or ejected them faster with more energy than did, say, the spectrum closer to red. And then going so far down below red, it actually didn't eject any electrons. That means the oil didn't come back together. It would stay apart. Didn't have enough energy to release those extra electrons. So that's a real problem for Newtonian physics, because Newtonian physics said that, well, if I increase the intensity or luminosity of the light that is hitting the disk and ejecting the electrons, then I can eject the electrons. There shouldn't be a problem. It shouldn't be dependent on color. Color has nothing to do with it. Well, color did have something to do with it. And so you had all these problems. Again, existing was a huge problem. The spectrum and it being different colors was a huge problem. The ultraviolet catastrophe was a major problem. And the fourth problem was this photoelectric effect. And we actually see the photoelectric effect today in car door openers and different types of electronics that detect light and sensors in terms of opening doors and such by detecting light. Now, it was very simple. It was a very simple device that I'm talking about, but it's become more advanced, and we now use semiconductors and different aspects to create the photoelectric experiment or the photoelectric cell to detect light. So now quantum physics is a paradigm shift. It's a different way of looking at the world, and that's why it's so important to understand. And I think that's why physics students and physics in high school does a huge disservice to students by explaining the world through Newtonian mechanics, that things work in this like clockwork universe. Things, we'll eventually find out things do not work out that way. So until next time, follow me on Instagram and TikTok at Professor Matt View, and stay curious, my friends.